Okay, so in this video, we're going to be going through questions 7 through 15 from Practice Exam 3, starting out with some more probability and two-way tables. So questions 7 through 11, I'll refer to this top scenario and 2x2 table here. So it says researchers conducted a medical study to find out if treating a sinus infection with an antibiotic reduced the length of the sinus infection. The study included 241 patients who were diagnosed with a sinus infection. There were 113 patients randomly assigned to receive the antibiotic. The remaining patients received sugar pills, so that would be our placebo. The patients were contacted regularly to find out when each patient stopped having sinus infection symptoms. The results of the study are presented in the table below. So vertically, they're just splitting this up by treatment. So the left column, this is data for the participants that were given a sugar pill or basically no treatment. On the right, we have data from those given antibiotics, so those who were given the treatment. And going across, we have length of sinus infection, and they've just broken that down into two separate categories. Your infection was either less than 10 days long or 10 or more days long. Question number 7 says, those who received which treatment, the sugar pill or the antibiotic, were more likely to have a sinus infection that lasted less than 10 days. And so our options are either the sugar pill group, the antibiotic group, or they were equally likely to have a sinus infection that lasted less than 10 days. So you want to be a little bit careful with this question. If we just look at the data table, where it has the less than 10 days category, it says there were 80 people or patients who took the sugar pill or the placebo and their infection was less than 10 days. And there was also 80 patients or subjects who were given antibiotics and their infection lasted less than 10 days. So looking at those two 80s, it could be easy to just jump to the conclusion that the correct answer is C. They were equally likely to have a sinus infection, but that's not necessarily the case because we have different total amounts for those who received the sugar pill treatment and those who received the antibiotic treatment. So while the sugar pill and the antibiotic may have the exact same value here, it doesn't necessarily represent the same proportion or likelihood that their infection lasted less than 10 days. So we do want to actually come up with that probability and then compare our two values. So we'll work out the amount for those taking the sugar pill or placebo, and then we'll do the same process again with those taking the antibiotic. So first case, they were given the sugar pill, so we have two pieces of information. One, they were given the sugar pill, and two, they had a sinus infection that lasted less than 10 days. So in this case, this would be an example of conditional probability, because by saying we're only looking at those who took the sugar pill, we're now limiting the total amount. When we go to calculate the probability, we're not going to use the overall total of 241, but we're just going to be using the total for only those who took the sugar pill. So if I were to write this out as a probability statement, remember, conditional probability is the one that has that vertical bar. So it would look something like this. The probability that your sinus infection lasted less than 10 days, given that you took a sugar pill. Okay, so now to calculate, on the bottom we always have our total value, and again in this case we're just looking for the total number of participants who took the sugar pill, which was 128. That'll go on bottom. On top, we're looking for, out of that 128, how many of them had an infection that lasted less than 10 days, and that would be 80. And in just a minute, I'll put that in my calculator and see what that is as a decimal. So now I'm going to set up the probability for those who received an antibiotic. So same idea, this is also a conditional probability. So in this case, we're trying to figure out what is the probability that you had a sinus infection that lasted less than 10 days, given that you were taking the antibiotic. Okay, so on the bottom here, our total amount. And again, here we're just restricted to looking at those who took the antibiotic. And there were 113 total patients who took the antibiotic. That goes on bottom. And on top, we're looking for, of those 113, how many had an infection that lasted less than 10 days, which again is 80. Okay, so if I were to put these into my calculator, the first one with our sugar pill, 80 divided by 128 is equal to 0.625. And the probability for our antibiotic group, I have 80 divided by 113, which equals 0.708. So now we need to interpret these results. So again, they were asking for which group was more likely. So in this case, since they're asking for more likely, we're looking for the larger value or larger probability. If they had asked for less likely, then we'd be looking for the smaller amount. But in this case, we're trying to figure out which group would be more likely to have an infection that lasted less than 10 days. And in this case, if we compare our two values, 0.708 is larger, so it would be our antibiotic group that would be more likely to have a sinus infection lasting less than 10 days. So the answer for question 7 is B. Question number 8. What is the probability that a randomly selected patient received the antibiotic and the sinus infection lasted more than 10 days? So here at the beginning they've specified we're looking at the probability that a randomly selected patient. So our randomly selected patient means we're going to be looking at the complete total. We're not limited to looking at one particular group, but any randomly selected patient. And then there's 2 criteria we need to fulfill. 1, they have to have received the antibiotic. And 2, their sinus infection had to last more than 10 days. So this would be an example of joint probability. We have 2 characteristics we need to fulfill. So if I were to write this out as a probability statement, I would have what is the probability that a randomly selected patient received the antibiotic and their infection was 10 or more days. Okay, so on the bottom, our total amount, and again, we already said we're looking at all patients, so there was a total of 241 patients. And now for the top, we're looking for those that received an antibiotic. So on the chart, I'm just going to be looking at the antibiotic column. And the other criteria was their infection lasted more than 10 days, 10 or more days. And that would be the bottom option here. So here, the value 33. This is representing how many patients got the antibiotic treatment and had a sinus infection lasting 10 or more days. Okay, so now all's left to do is type that into our calculator. 33 divided by 241. And that equals 0.1369. Our answer choices are all rounded to 3 decimal places. So if I had to round the last of the 3, we'd be looking at the 6, which is going to round up because of that 9 behind it. So in this case, the probability that a randomly selected patient received an antibiotic and had a sinus infection lasting 10 or more days would be 0.137, which again would represent the same thing as 13.7%. So if I randomly selected one patient out of all 241 patients, there's a 13.7% chance that that random person would be somebody who received the antibiotic and had the sinus infection lasting 10 or more days. So in this case, the correct answer for 8 is A. Question number 9 says, what is the probability that a sinus infection lasted less than 10 days for any patient? So again, here we're looking at any patient. We're not limited to a subset. So I know when I set up my probability fraction, I'm going to have 241, the entire total number of patients, as the denominator. So we're looking at all patients, and in this case we only have one criteria we're trying to meet. We're just looking at the criteria of those who had a sinus infection lasting less than 10 days. So far we haven't had an example question like this where we were just looking at one criteria, meeting one criteria. So in this case where we just have one criteria we're trying to meet, that's what's called marginal probability. So I'll go ahead and write my probability statement. So we're looking at what is the probability that a randomly selected patient had a sinus infection lasting less than 10 days. So a much simpler probability statement, again, because we just have to worry about one criteria. So on the bottom, we want the total amount. So the total number of patients in this study was 241. And on top, we're looking for how many of those 241 patients had a sinus infection lasting less than 10 days. So I'll go back up to our 2x2 table. And here's where we have the length of sinus infection. I'm looking at less than 10 days. So if I go all the way to the right, there was a total of 160 patients or participants who had a sinus infection lasting less than 10 days, regardless of which treatment they were assigned to. Okay, so now I can divide that out on my calculator. 160 divided by 241 is going to be 0.6639. In this case, our answer choices have been rounded to 3 decimal places, or the thousandths place. So I'll go ahead and round my answer so it's the same length, 0.66, and then that 3 would round up to a 4. So what this tells us is that if I were to randomly select any one of those 241 patients, there'd be a 66.4% chance that that random person I selected was someone who had a sinus infection that lasted less than 10 days. So for question number 9, our correct answer would be C. So moving on to question number 10. Okay, so 10. Which of the following is a reasonable approximation So that tells us it's probably not going to be exact. It's not going to exactly match one of these choices, but we're looking for which answer choice it matches most closely. So which of the following is a reasonable approximation for the chance that a sinus infection would last 10 or more days for a patient who received the antibiotic? So in this case, this is going to be an example of conditional probability, because when I go to calculate the probability, I'm not looking at the absolute total amount of patients, but I'm restricted to just looking at the total amount of patients who had received the antibiotic. So when we calculate our probability, we calculate it as a decimal, which is easy to interpret as a percent. So one thing we might want to do is think about what each of our answer choices would mean, or how it would be represented as a percent. So A, it says about a 1 in 10 chance. So that means we're looking for something that's around 10%. Choice B says about 2 in 10 chance. So a 2 in 10 chance would represent 20%. C, about 3 in 10 chance, which would represent 30%. And answer choice D, about a 4 in 1 chance, which would mean about 40%. So I'll go ahead and write my probability statement. Again, we're just looking at those who received the antibiotic. And of those, what are the chances that the person had a sinus infection that lasted 10 or more days? So we're looking at what is the probability that we had a sinus infection lasting 10 or more days, given that we were in the antibiotic treatment group. We were given the actual antibiotic. Okay, so on the bottom, we want the total amount. And again, in this case, we're limited to the total amount who had an antibiotic. So if I look back at our table, just looking at those patients who received the antibiotic, so there were a total of 113 patients receiving the antibiotic treatment. And now we're looking for the chance that one of those had an infection lasting 10 or more days. So I'll look back at our table. On the left here, we have 10 or more days. So there were 33 patients who had an infection lasting 10 or more days that were given an antibiotic. And I can go ahead and put that in my calculator, divide it out. 33 divided by 113, that is about 0.292. And again, if I wanted to express that value as a percent, I would just multiply by 100 or move the decimal places 2 times to the right. So a probability of 0.292 would be equivalent to 29.2%. So if I look back at my answer choices, there is not a choice that is exactly 29.2%. But again, they're asking which would be a reasonable approximation. So we're just looking for which choice is closest. So the answer choice closest to 29.2% would be 30%. So a reasonable approximation would be about 3 in 10 chance. So the correct answer for number 10 is C. Okay. So last question dealing with this scenario, number 11, says, imagine that 1,000 patients with sinus infections were treated with the antibiotic. Approximately how many of them would you expect to stop having sinus infection symptoms in less than 10 days? So at first this looks a little different than the previous problems. They're not asking us to come up with a probability. Instead, they're asking us to come up with a number representing about how many patients out of 1,000 were treated with an antibiotic and had sinus infection symptoms that lasted less than 10 days. So even though they're not asking for a probability as our final answer, that's actually going to be the first step in the process, is figuring out what's the probability that someone had symptoms for less than 10 days, given that they were treated with the antibiotic. So this would be conditional probability. We're not looking at any randomly selected patient, but we're just limiting to looking at those patients who had taken the antibiotic. So I'll write my probability statement. So the probability that we had symptoms lasting less than 10 days, given that we were in the antibiotic group. So on the bottom, I want the total amount, and in this case, just the total amount of those who received an antibiotic. So if I look at the chart, there were a total of 113 patients that received the antibiotic. Of those 113, we're looking at how many had symptoms that lasted less than 10 days. So again, looking back at our table, less than 10 days, there were 80 of those patients. And now I can go ahead and divide that out on my calculator. 80 divided by 113 would be about 0.708, or it'd be equivalent to 70.8%. So again, what this is telling us is if I randomly picked someone from the group who did get an antibiotic, there'd be a 70.8% chance that their symptoms lasted less than 10 days. Okay, so now they're saying, imagine that we had 1,000 patients who had a sinus infection treated with an antibiotic. About how many of those 1,000 patients would we expect to have symptoms lasting less than 10 days? So we know that we would expect about 70.8% of the patients to have symptoms lasting less than 10 days. So at this point, what we're really trying to figure out is what is 70.8% of 1,000. How many of those 1,000 patients would we expect to have symptoms lasting less than 10 days? And so, again, if we're asked to find a percent of a value, we want to write the percent in decimal form. So again, 70.8% is equivalent to 0.708. And now we just need to multiply that by the total amount. In this case, they said, imagine there was 1,000 patients total. So if I were to multiply 0.708 by 1,000, that would equal 708. And again, if I look at the answer choices, there isn't one that's exactly 708, but that's okay. They said approximately, not exactly, so we just want to find the answer choice closest to 708, which in this case would be 710. So the correct answer would be C. Okay. So now we're going to move away from the sinus infection scenario. Question number 12 says, for a particular test, the probability that a student gets an A is 0.3, and the probability a student gets a B is 0.5. What is the probability that a student gets an A or a B? So it's always a good idea to start by writing down what information you do know. So what we do know is that the probability of a student earning an A is 0.3 or 30%. Other piece of information we know for sure is the probability that a student gets a B, which is 0.5 or 50%. So we want to read the question carefully because there's going to be just one word that determines the difference in what procedure we're going to use to come up with our final answer. So they're asking, what is the probability that a student gets an A or a B? So, or means one or the other. So, what's the probability that they got either an A or they got a B? So, to determine the probability in this case, when we have an or situation, what's the probability of this or that? What's the probability of event A occurring or event B occurring? What we do in this case is just add the two individual probabilities together. So the probability of event A occurring, the student getting an A, was 0.3 plus the chances of event B occurring. So the probability that the student got a B grade, 0.5. And adding those together, we come up with the answer 0.8. So in this case, the correct answer is D. And again, this might be something you want to put in your notes for the test. So on a probability question like this, where you have multiple events occurring, if they're using the word or, what is the probability of this or that occurring? That means we want to add the individual probabilities together. So or equals add. Okay. Question 13. You are about to roll 2 fair 6-sided dice. So you're just rolling 2 dice. You hope to get a double 6, which means both dice show a 6 or both dice land on a 6. What is the probability of rolling a double 6? So this is also a situation where we're trying to determine the probability for an event that has multiple parts. Here we can sort of think of the dice separately. So what happens with the first dice? I'm going to think of that as just event A. And what happens with our second dice, what number that lands on, I'm going to think of that as a separate or second event. I'll just think of that as event B. So just like question 12, we have 2 separate events we're looking at. But the key difference here is in question 12, they were asking what are the chances that either event happens, either event A or event B. But in answering question 13, what's the probability of rolling a double 6? Here we need both dice to land on 6 to get a double 6. So we're looking at what is the probability that dice 1 lands on 6 and that dice 2 lands on a 6. Or what is the probability of event A and event B occurring. So we'll start by looking at the individual probabilities. So if I start with my first die, I'm thinking about what is the probability that that die lands on a 6. So on the bottom, we always have the total. So if I have a regular dice, there are 6 different numbers, 1, 2, 3, 4, 5, 6. So I have a total of 6 options for that die. And of those 6 options, we're only interested in one of those numbers, the 6 in particular. So the probability that just rolling one individual die and having it land on a 6 is 1 in 6. And in this case, I noticed that my answer choices are in fractions, so I'm going to leave the probability as a fraction instead of converting it to a decimal. So now we want to take a look separately at what happens with our second dice, which we're calling event B. So if I'm only looking at that second dice by itself, we're not taking into account the first dice. I'm just thinking, what is the probability that that second die lands on a 6? So again, on the bottom, I want the total number of outcomes, which is still 6. There's 6 numbers on the die. And of the total possibilities, there's only one we're interested in, which is landing on a 6. So if I were to look at event B all by itself, its probability would be 1/6. So we have the individual probabilities, but now we want to put them together to determine what's the probability of both of those happening. So not one or the other, but both. So up above, when we saw the word or, that was a clue that we wanted to add the individual probabilities together. If we have an and situation, we need both event A and event B to happen. In this case, we would multiply the individual probabilities instead of adding. So the probability of event A taking place was 1/6. Probability of event B taking place, also 1/6. So I'm just going to multiply those fractions together. If it's been a while since you've worked with fractions, it's pretty easy. I'm just going to separately multiply together the top numbers and then the bottom numbers. So I'll start with the top numbers. 1 times 1 is just 1. And now to the bottom, I'd have 6 times 6, which would be 36. So that tells us that if I were to roll 2 dice, the chances of both of them landing on a 6 would be 1 out of 36. So in this case, our answer would be D. And again, maybe something you'd also want to put in your notes, if we have several events taking place and it's an and situation, this needs to occur and this also needs to occur. That is an indication for us to multiply together the individual probabilities. So or means to add, and means to multiply. Okay. Question number 14 says, for a particular history exam, being male and passing the test are dependent. What does it mean for these two events to be dependent? And we have 4 answer choices to choose from. First, we want to start by thinking about what does it mean if these events are dependent. And it's pretty much what it sounds like. If 2 things are dependent, that means one of them happening depends on the other happening. So in this case, the two items that are dependent are being male and passing the test. So what this tells us is that being male or not is related to passing the test or not. So this is essentially telling us that how well you did on the test depends on your gender, depends on being male or female. Okay, so again, the question was for a particular history exam, being male and passing the test are dependent. What does it mean for these two events to be dependent? Answer choice A says this means that male students are more likely to pass the test than female students. So we do know that being male or female is related to how well you do on the test, but they did not tell us what that difference meant. They did not say whether being male was going to mean you do better on the test or worse on the test. So we just don't have enough information to say that it means male students are more likely to pass than female students. Choice B, sort of the opposite. Male students are less likely to pass the test than female students. And again, similar to answer choice A, we know their chances of passing are going to be different, but we don't know what direction that is, whether it's less likely or more likely, so we don't have enough information to make that claim. Answer choice C, male and female students are equally likely to pass the test. So that might seem like a reasonable conclusion. They're both equally likely. But in this case, we can actually rule that out because they told us that these two things are dependent. So passing the test is dependent upon whether I'm male or female. So that means how well a random male did on the test and how well a random female did on the test cannot be equal to each other. Otherwise, being male and passing the test would not be dependent. So process of elimination leads us to answer choice D, which states males and female students have different probabilities of passing the test. And that is the correct answer. So we don't know if males are more likely or less likely to pass the test than females, but because being male and passing the test are dependent, we know that the probabilities have to be different for males and females. So again, being male and passing the test being dependent, what that really means, or how you can think about it, is it means your grade on the exam. My pen's running out. Depends on whether you're male or female. And it's this fact that allowed us to eliminate answer choice C males and females were equally likely to pass the test. That cannot be true if your grade on the exam depends on whether you're male or female, implying males and females got different grades. Okay, so last question in this video, we're going to take a look at number 15. So 15 says, which of the following is a discrete random variable? We have 4 choices. A, weight of a cat measured in ounces. B, total time a cat sleeps in a day. C, height a cat can jump measured in centimeters. And D, number of times a cat fetches a ball in 5 minutes. So all 4 answer choices are talking about a cat carrying out some sort of action, and these are all quantitative variables. These are things that would be described with numbers, but obviously one of them has to be different than the other. We're looking for which one is a discrete random variable. So you sort of want to hone in on that word discrete. So something that is a discrete random variable is something you can count and come up with an exact value. One easy way to think about it is it has to be something that you can count in whole numbers, usually, or you can count it on your fingers. So discrete, there is just one exact value, not an infinite number of values. So if we look at answer choice A, weight of a cat measured in ounces. So that sort of looks like it could fit these parameters. Maybe the cat weighs 46 ounces. Maybe the cat weighs 47 ounces. But there's also values in between those two numbers that are possible. It's possible the cat weighs 46.5 ounces. I could take it out to another decimal place. Let's say the cat weighs 46.51 ounces. If I had a measurement scale that went out to the thousandths place, we could also do that. So maybe the cat weighs 46.517 ounces. Or maybe the cat really weighs 46.5189 ounces. And we could keep doing that forever and ever. There are an infinite number of weights. So that means it is not discrete, but it'd be what's called a continuous random variable. There's an infinite number of possible values. So B, total time a cat sleeps in a day. Here, same idea. I could say the cat sleeps for 8 hours a day or 9 hours a day. But I could break that up further. Maybe the cat sleeps for 8 hours and 10 minutes. I could break that up further. Say maybe the cat sleeps for 8 hours, 10 minutes, 22 seconds. And I could keep going. Maybe the cat sleeps for 8 hours, 10 minutes, and 22.5 seconds. So there'd be an infinite number of values that variable could take on. C, height a cat can jump measured in centimeters. So this is also a case where we could have an infinite number of values representing that variable. The cat could jump 57 centimeters. The cat could jump 57.5 centimeters. The cat could jump 57.5698 centimeters. And we could keep taking that value out. There would be an infinite number of values that variable could take on. So process of elimination leads us to answer choice D. Number of times a cat fetches a ball in 5 minutes. So this would be a discrete random variable. This is something that can take on a specific value. We're not left to an infinite amount of values. So if I'm measuring the number of times my cat fetches the ball in 5 minutes, I could say maybe it fetched the ball 5 times. Maybe it fetched the ball 6 times or 7 times. But I can't say the cat fetched the ball 5.8 times, or the cat fetched the ball 7.36524 times. So that phrase number of times, that's a good indicator when you're looking for something that's a discrete random variable. There's only specific values it could take on. We're not left with an infinite number of values. Thus, D would be the correct answer for 15.